evening, everybody. This is Caleb here with Indiana Storm Chasing Network. We are going to be doing our severe weather workshop here this evening. We'll wait a few more minutes here to let a few more people join on in. So welcome if you are in. So we got a few of you in here. We'll wait for a few more here, and then we'll go ahead and get started. We got Julie in here. Welcome, Julie. Again, we'll get started here in just a few minutes here. We'll let a few more people join in. If you're in, go ahead and make a comment in the chat. Let us know you're here, and then we will get started here before too long. We'll let a few more people join in before we get started. Again, my name is Caleb. I am here with Indiana Storm Chasing Network, and we'll be doing our Severe Weather Workshop 2025 tonight. We're going to be talking about what it means to be severe weather prepared for Indiana. We'll talk about what types of thunderstorms and severe weather events we see in Indiana and across the Midwest. And we'll have some Q&A here at the end. So we got Freedom in here. Great to see you, Freedom. Yeah, that cold front's starting to work through the region, that's for sure. Still pretty warm across much of Indiana. A little bit cooler across northwest Indiana. Gary, Indiana, you guys kind of lucked out today. You guys are in the 40s most of the day, but we'll warm up here over the next couple of days. So, and widespread 70s by the end of the week. So we got that to look forward to. So again, if you guys are in here, go ahead and jump in the chat here. Let us know we're here, and we'll go ahead and get started. Again, my name is Caleb. I am with Indiana Storm Chasing Network. And we'll go ahead and get started here. It is 7:24 p.m. and the sun's still out, believe it or not. So got that to look forward to as well. All right, well, welcome everybody, and we'll go ahead and get started here before too long. And doing that, we're going to go over the topics here of tonight's Severe Weather Workshop 2025. We're going to be talking about severe weather facts here across Indiana and across the region as a whole. We're going to understand severe weather risk levels from the SPC and our forecast that we put out here at Indiana Storm Chasing Network. We're going to go into some terminology a little bit. We're going to talk about warnings and watches, what that means, and what you should do to be prepared for when either of those are issued. We're going to go into that. We're going to talk about severe weather safety. Where do you need to go? What do you need to do in the event of severe weather? I know it's 2025. We have technology out the wazoo, but yet some people don't know the best way to get warnings or don't really know what to do. So we're going to talk about that here tonight. Sometimes too much technology can be a problem with that as well. So we'll talk about that. And then we're going to go into, at the very end, severe weather identification. We're going to go into some quick identification. You know, what are we looking at here? And then we'll have a short quiz at the end. Yeah, I know nobody likes quizzes. I promise it's easy. We're not going to flunk anybody or ridicule anybody, I promise. So it's going to be real easy. We'll get through it together, and I'll even give you the answers at the end. So you got that to look forward to. And then we'll do a quick Q&A session before we wrap things up. So with that being said, let's go ahead and get started. It is 7:26 Eastern, so here we go. So severe weather facts here in Indiana. We can have severe weather in any month of the year, including tornadoes. In the state of Indiana, we have had recorded tornadoes in every single month of the year. The only state actually in the Great Lakes region is Michigan that has not had a tornado in every single month, but they're close. So severe weather can happen any time of the year in Indiana, so it's important to be severe weather prepared, especially now that we are in the month of March. March is really the season of change, when we're starting to see our air masses shift. We're starting to see our overall climate shift gears from winter to spring. There's a lot of volatility this time of year. There's just a lot of change. Like today, for instance, many of us were in the 60s and 70s, and a few weeks ago, there were cold weather advisories across the state for wind chills minus 15 and below. So a lot of change going on this time of year. So our most favorable months are April through June, historically in Indiana. June is actually our highest grossing tornado month in Indiana. I know a lot of times people will think May is, but actually in Indiana, June is historically our most active month for tornadoes here in the state of Indiana. But again, tornadoes have occurred and can occur any time of the year here in Indiana. So it's important to be ready for them any time of year. Indiana, we average 22 tornadoes a year in Indiana, which is on average. Last year, we had 57. 57 last year was actually the second highest grossing year in Indiana's history. since records began in 1953. Our highest grossing year was 72 in 2011. That was our highest year on record in Indiana. Last year was 57, which was number 2. Number 1 was 2011, which had 72. So the average tornado lead time last year in 2024 over the entire United States was 13 minutes. Again, not a lot of time. However, time is increasing as we go into the future here. Technology has really paved the way for that. You go back even 10 years, average lead time was 5 minutes. So over time, lead time has really increased, and a lot of that has to do with advancements in technology. Again, wonderful staff, the National Weather Service, who issue those. So a big shout out to them who work very, very hard during the spring months to go ahead and issue those warnings. However, lead time is not always 13 minutes. It can be as little as 0 up to 13 minutes. So always prepare as if you have seconds to minutes when a tornado warning is issued. But as we go into severe weather, here are some facts and terminology that you're going to need to be familiar with as we go throughout the season. These are risk levels, 1 out of 5. These are issued by the Storm Prediction Center, which is a branch of the National Weather Service, or NOAA, the National Oceanic and Atmospheric Administration, and they're located out of Norman, Oklahoma, just outside of Oklahoma City. These are the guys that will be issuing our day 1, day 2, day 3 severe weather outlooks. A lot of us are familiar with these, but in case you're not, we're going to go ahead and go through them. So the first stop on our list will be the light green box over on our left. This is a no severe thunderstorms expected. Again, this is a general thunderstorm outlook. What we can expect with these are just general thunderstorms, as it says. No severe weather expected, but again, all thunderstorms do have a risk for, lightning. Lightning does not make a storm severe, but it is a hazard in of itself. It can cause damage. It can cause fires. So it is something that you need to heed caution when thunder roars go indoors. So that's why this risk exists. As we go up the scale, number 1, marginal risk. Isolated severe thunderstorms are possible. The Storm Prediction Center will issue this on days where we don't expect widespread severe. We're not expecting an outbreak, but there's enough ingredients starting to come together where they will go ahead and pull the trigger when we could see perhaps a few storms that are strong to severe. But overall, they're usually limited in duration. They're not long-lived, but we could have a few storms start to get an attitude on 1 out of 5. As we move up to 2 out of 5, this is our slight risk. This is when we start to see a little bit more widespread in coverage. Again, an outbreak is not expected at this level, but we do expect a few stronger storms, or more severe thunderstorm warnings being issued as we have more confidence in that, as a slight risk is issued. Again, short-lived and or not widespread. However, you could have an isolated intense storm possible. Now, what does that mean? That means you could have strong winds greater than 60 miles per hour, or perhaps some larger hail greater than quarter size, maybe getting into the 1.5-inch range once we get into our slight zone. As we move up the risk, 3 out of 5, enhanced. This is when we start talking and start upping our wording once we get to 3 and higher. Once we have an enhanced risk in place by the Storm Prediction Center, they usually issue this in the event of a larger severe weather day where widespread severe weather is anticipated, where we have numerous severe storms possible, not just in one area, not just a few storms getting an attitude. This is normally issued when we have a lot of ingredients starting to come together for widespread severe weather. So we have more persistent, more widespread, and a few intense storms are possible too. Getting into that, 70+ mile per hour range is possible for winds, or perhaps a tornado or two in the enhanced risk. And that's 3 out of 5. As we move into number 4, 4 out of 5, this is when we start talking about, all right, are we going to have an outbreak? Are we going to have widespread severe weather? The Storm Prediction Center usually issues moderate or high risks on the day 1 event. Rarely do you see a moderate risk or a high risk issued, days in advance. This is something they usually issue on the day of, or if not the night before. And the reason for that is these aren't used overly often, especially here in Indiana. The Storm Prediction Center likes to have high confidence before they issue a moderate risk here in the region, especially anywhere in the United States, really. When a moderate risk is issued, widespread severe storms likely. This is when we start talking about a severe weather outbreak in this category. We have long-lived storms, whether that's a derecho, tornadoes, whatever the risk is, it's expected to be widespread. So widespread severe weather is expected. As we go into number 5, this is the 5 out of 5. This is the highest level that the SPC can put out. This is usually reserved for high impact events, high impact derechos, high impact tornado outbreaks where violent tornadoes are expected. Derechos are expected where widespread winds of significant winds of 80 plus miles per hour are expected over a grave duration. High risks are very rare in the United States. They aren't issued very often. Usually we see only 1 or 2 a year, and that's max across the entire United States, if that. Sometimes we don't get them issued at all every year. Our last high risk here in Indiana was 2013. We'll talk about that here in a little bit. So we don't see them very often at all, which is good. They're typically reserved for your high-end events, high-impact events where you could have significant risk to life or property is when a level 5 out of 5 is issued. Here at ISCN, we have very, very similar categories. We go anywhere from a general thunderstorm to an extreme risk. General thunderstorm being just like the Storm Prediction Center. Thunderstorms are expected, but not severe. Just your garden variety thunderstorms, perhaps maybe some small hail, gusty winds, and heavy downpours. And that's with any thunderstorm across the United States. Every thunderstorm poses that risk for heavy rain, lightning, etc. As we go up the risk, we have added a limited risk. And a lot of you have asked what that is. And we issue that to kind of bridge the gap between a marginal risk and a general thunderstorm risk. A lot of times, if the confidence isn't high enough to where the data isn't there to have a marginal risk, sometimes you can have 1 or 2 stronger storms. This is kind of your sub-severe category, but your strong category where you have special weather statements issued for, pea to nickel size hail and 40 to 50 miles per hour winds. That's kind of this category here, the blue range. Once we get into your low risk, medium, and elevated, that's your more marginal, slight, enhanced, moderate, and then your high risk would be your extreme risk up there as well. So that's kind of the breakdown of how we do our forecasting here at ISCN. Again, we'll try to communicate any severe weather risk that we see in the state of Indiana or even the Great Lakes as a whole days in advance as we can. Again, sometimes we can't always do that. It really just depends on our confidence level and how confident our forecast models are as well. If we see a lot of change and uncertainty in our models, we may hold back on a forecast another day just to let that data be further analyzed until we have that confidence before we issue a severe weather outlook. We try to be very cautious with that. And with that being said, we need to talk about what the difference between a watch and a warning is. A lot of people don't know. And the biggest takeaway is a watch is be prepared and a warning is take action. So if you don't get anything else out of tonight, this is the main takeaway I want you guys to get. When a watch is issued, it means conditions are expected to become favorable for the formation of severe thunderstorms and tornadoes for a tornado watch. A severe thunderstorm watch, tornadoes may not be expected, but conditions are expected to become favorable for severe weather, including hails and damaging winds. For a tornado watch, conditions are expected to become favorable for the formation of severe thunderstorms and tornadoes. Be prepared. That's the main takeaway for a watch of any kind, whether it's a flash flood watch, severe thunderstorm watch, tornado watch. Doesn't matter what the watch is. A watch is issued specifically for a hazard that is expected to become possible, if not favored, for that afternoon or for that time period. So that's the main takeaway for a watch. When a tornado warning is issued, it means take action. Even a severe thunderstorm warning, any warning whatsoever, take action is the requirement for when that is issued. Not take action in 5 minutes, take action immediately upon issuance when a warning is issued of any kind. A tornado warning is issued when a tornado has been spotted, indicated by radar, or radar indicated that a tornado may form in any minute. Usually they issue a tornado warning when rotation is tight enough on radar that it meets a threshold that historically produces tornadoes. And that's when the National Weather Service will issue one with a radar indicated tag. It means one has not been spotted yet, but it could form at any moment, so take action and take cover. When it has a radar confirmed tag on it, it means the radar has confirmed that a tornado is on the ground and is occurring, so take shelter. Tornado emergency is the highest level of a tornado warning. These are very rare. Used when they are reserved for when there is a significant threat to human life and or property, usually reserved for a violent tornado that is producing catastrophic damage. So a violent wedge tornado in progress posing a significant risk to life or property, get underground now, is usually the wording with this tag. This is also a take action tag. as there is a large and extremely violent tornado in progress. That is when this tornado warning is issued. These are very rare. Seldomly do we see these in Indiana. No, we have seen them before, but they're seldomly used and very rare. These are reserved for the biggest, worst tornadoes that Mother Nature can dish out. Now, as we go into severe weather season, a lot of people ask, what makes a severe thunderstorm severe? What is going on, or what threshold needs to be met for the National Weather Service to issue a severe thunderstorm warning? Well, let's talk about that. So for a severe thunderstorm, we have to have a certain criteria for a severe thunderstorm warning to be issued. And the baseline for that criteria is, one, we need to have strong winds of at least 58 miles per hour, if not greater. We have to have strong winds of 58 miles per hour. And a lot of times we'll see a warning tag for 60 miles an hour. That's usually the baseline that the National Weather Service will issue a severe thunderstorm warning on. Large hail. We have to have hail that is quarter size or 1 inch diameter or greater to be a severe thunderstorm warning. Or a tornado. A tornado will also make a thunderstorm severe even without hail or winds. So that is the baseline for a severe thunderstorm warning. Now, the National Weather Service may upgrade that warning to different tags, and we'll talk about that here in a second, as the risk increases in severity. So severe thunderstorm warnings, a lot of people don't know this, but there are different kinds. There are different levels. Think of it as a level 1, level 2, and level 3. So level 1, the baseline, is what we just talked about, where quarter-size hail and or 58 mile per hour winds or greater are possible. Usually the warning tag will come across the radio, for 60 miles per hour winds and quarter-size hail. That's historically what we see the most often in Indiana, is that right there. But occasionally we get stronger storms that may need to have increased wording with them. So the National Weather Service may have a considerable tag on that. And that'll come across the emergency alert system as such as well. So if you have a NOAA weather radio, when a warning goes off, you'll hear that description read as it goes through and plays the warning. So a considerable tag will be issued when we have hail that has reached golf ball sized in diameter, which is 1 3/4 inches. So pretty good size hail. Once you get starting to golf ball and larger, that's really when it becomes a significant risk to injuries, animals, vehicles, and even structures. We start seeing a lot of roof damage and even siding damage once we get the golf ball size. Once we get to destructive size, a lot of times the National Weather Service will have a PDS tag on it, or particularly dangerous situation. This is when we can have significant risk to life or property when baseball size hail is reached, which is 2 3/4. So it's quite a significant jump there, and or 80 or greater miles per hour winds is possible. So think a big windstorm, think of like a derecho for a destructive tag, a big powerful wind event, or a supercell thunderstorm that has a very powerful updraft and is able to produce baseball size hail. Sometimes we'll see a destructive tag on that. Again, we don't see that used too often here in Indiana, but it can happen on those bigger days where we have a lot of energy, big powerful thunderstorms in progress across the state. But it's not just limited to severe thunderstorm warnings where we have those different levels. It also happens in tornado warnings. We talked about a couple a few minutes ago, but we'll go through them here. So the level 1, or the baseline, is tornado radar indicated. We see this a lot in the springtime and here in Indiana. A severe thunderstorm is capable of producing a tornado at any moment, but no tornado has been confirmed yet. And that's the key word, yet. Tornado warnings should always be treated as if a tornado is in progress. The National Weather Service doesn't issue them for no reason. They have a valid accreditation to issue those warnings based on radar and based on the velocity signature that they see. A lot of times the threshold has been met. There's strong enough rotation that historically can produce a tornado, so they'll issue a tornado warning. That is what that level 1 means. As we go up to a level 2, a tornado has been confirmed either by radar or by weather spotters. This means that there is a tornado on the ground. It is causing damage. You need to be in your safe place immediately. As we go up in criteria, the National Weather Service may issue different tags, as you will, to these tornadoes. When there's a larger tornado on the ground, they'll issue a PDS warning. And that stands for a particularly dangerous situation, just like what we have on the destructive warning for a severe thunderstorm warning. Same applies for a tornado warning. A PDS tag will be issued, and that is when there is credible evidence that a tornado is producing considerable damage. Think of a wedge tornado, a big, powerful tornado, and usually these are long-tracked tornadoes as well. Usually these are on the ground for a decent amount of time. Think greater than 5 miles, not just touchdown, they lift back up and do their thing and they're gone. Normally a PDS tag is issued when you have a big tornado on the ground. It is causing damage. You need to be in your safe place. And again, the highest level is that tornado emergency, and that has a considerable or a catastrophic threat tag on it, meaning that a violent tornado is on the ground. It is causing a severe threat to human life, and catastrophic damage is occurring. That means a wedge tornado is on the ground, a very powerful tornado is on the ground, catastrophic damage is occurring, but these are only issued, again, this is key, they are only issued when reliable sources confirm that a violent tornado is in progress, whether that's radar or emergency management or trained spotters. Again, the National Weather Service will not issue this unless they have credible evidence that a violent tornado is occurring. So they try to reserve that just so that it doesn't get brushed off. Again, they don't issue these unless they are certain. So that's kind of a look at the terminology of warnings that we have here in Indiana. So we do see quite a few, but let's talk about, what does that look like on radar? What kind of storms do we see in Indiana? We get a mixed package here in Indiana, and I know a lot of times Indiana gets the reputation, this is where storms come to die. Nobody chases Indiana, all the storm chasers are out in the plains, this is where storms come to die. Severe weather doesn't happen here. Well, that's not entirely true. And we'll talk about that. So the first category I want to talk about of what we see here in Indiana is called an ordinary cell thunderstorm. This is what we see in our general thunderstorm risk. Non-severe weather, but this is what an ordinary thunderstorm looks like. A lot of times these are termed pop-up thunderstorms. This is what we see in the summertime very often here in Indiana. A lot of times they pop up or bubble up in the heat of the day, and then they disappear once we get by sunset. So ordinary cell thunderstorms are also termed pop-up thunderstorms because they form in a conditionally unstable air mass. Think of it as the sun heats the ground, that air begins to rise, and it cools and becomes unstable, clouds condense, and we get thunderstorms. These are usually not necessarily associated with a cold front. Again, there's really no driving mechanism or forcing mechanism other than the sun or the heat of the day. They just bubble up, do their thing, and they disappear. But as with all thunderstorms, there are a few risks with them, even though they are non-severe. Ordinary cell thunderstorms or pop-ups can have small hail. Small hail is very common in thunderstorms. In fact, a lot of thunderstorms have hail just because they have an updraft. All hail isn't necessarily severe. A lot of times in ordinary cell thunderstorms, you can see hail between pea and dime size or even nickel in your stronger cells. Lightning. Again, that's what makes a thunderstorm, right? But a lightning does not make a thunderstorm severe. It is a hazard, and it should be treated with grave caution. However, it does not make a thunderstorm severe. Heavy downpours are also very common, especially in the mature stage of a thunderstorm. Again, you can see the stages here, the cumulus stage, mature stage, and the dissipating stage. Again, they bubble up, they do their thing, and then they disappear. And gusty winds are also a risk with ordinary cell thunderstorms as they kind of rain out and you have that downburst appear towards the end of its life cycle. Excuse me. So a lot of times this can also be termed a microburst or a wet downburst. Very common in your pop-up thunderstorms. Well, what exactly is a microburst? Again, they're very hard to detect on radar. A lot of times these will go without warning. Just because they cannot be seen on radar as well. It also makes them very tricky, but also very dangerous as well. Again, here's an example of what a microburst looks like in a thunderstorm. Kind of hard to tell there, but I put some arrows on it to kind of help. You can see this is also called a rain bomb. You have an intense downdraft coming down with your rain shaft there. You can see it bubble out against the front, called a rain foot there on the right arrow there on the right. You can kind of see how the rain shaft has a boot, as you will. That's as the rain and cool, dry air comes down to the ground, and then it disperses in all directions. This is what a microburst looks like in person. Now, on radar, the radar operator may not know this is occurring because they often occur quick, and they disperse, and they're done. But they can cause significant damages. In fact, a microburst is usually impacting an area less than 2.5 miles in diameter. Again, usually they're very localized. They can be much larger than that. You can also have what's called a macro burst, which is actually what's pictured here, that can actually be long-lived. It can impact a much graver area as well. Microbursts have been known to have winds up to 100 miles per hour. Again, not all microbursts are severe. In fact, 1 in 5 thunderstorms have a microburst at some point in time in their life cycle, but they can range with winds between 25 miles an hour and 100 miles per hour. Very rarely do we see microbursts in excess of 80 plus miles an hour, but they can happen. And they can cause serious damage with little or no warning at all. A lot of times these will go without a severe thunderstorm warning because of how quick they form, and the National Weather Service may not be able to see these on time as well. So another reason to go inside when, and just remember when thunder roars, go indoors. There's a reason for that. People have gotten hurt for not heeding that warning. Another type of storm that we see very often in Indiana, especially in the spring and the fall, we see what's called a QLCS thunderstorm. A QLCS stands for a quasi-linear convective system. This is a fancy term for a line of thunderstorms or convection, typically seen along a cold front. Again, this time of year, we get a lot of cold fronts coming through. We warm up for a day, and then the cold front comes through and kicks us back to where we should be this time of year, right? Well, a lot of times along that cold front, we'll get convection. Very, very commonly seen here in Indiana. Again, this one is across the south, but we can see them here in Indiana, and we do get them every year. We've already had one this year as well. So risks associated with QLCS are damaging winds, small hail, but there is also a non-zero tornado risk with QLCSs. A lot of times these are not long-lived tornadoes. These are quick spin-up tornadoes, but we can often get tornadoes when we have a QLCS setup. A lot of that has to do with converging winds right along the line here, and we'll go into that here. This is an example of what a QLCS tornado spin-up looks like on the leading edge of that line. This is a really zoomed-in view, but think of this as that line that we just looked at, but we're looking at a much smaller portion. QLCS spin-ups, or they're also called mesovortexes, are areas of embedded rotation that can form in QLCS thunderstorms. These are a lot of times little kinks, little notches on the leading edge of that, where you can get inflow and outflow, and you can actually get what's called a bookend vortex, and you can actually get embedded rotation in there. They spin up quickly, a lot of times in between radar scans too, making them very difficult. They're very tedious to forecast for your radar operators. The radar operators at the National Weather Service work very hard on QLCS nights because they don't take their eyes off the radar just because of how fast these things can spin up, do their thing, and dissipate. Sometimes they can produce a tornado between radar scans and lift without the radar operator even knowing it. So again, these can spin up very, very quickly. A lot of times these are also rain-wrapped tornadoes and difficult to see. A lot of times these are embedded in the rain and you can't see them coming. So another reason to be in your safe place during severe weather. But to kind of go through this diagram here, you can kind of see how it's bowed out in the front here. The top left picture there, you can see the word tornado. You can kind of see it. You can kind of see a little bit of a hook there on the leading edge at the north end of that bow echo. And you can also see a little bit of an inflow notch too, especially on your bottom picture there. They kind of drew it out with your cold front and your warm front. This is on the mesoscale. This is really, really small and localized, but the gust front of a thunderstorm acts as a cold front. And on the leading edge of that acts as a warm front. It's feeding on that warm, moist air as it's progressing along. But on the north end of that, you can have an inflow notch where warm, moist air is speeding in and you have really cold, stable air rushing out. Where those two air masses meet, you can get a couplet or an area of rotation, and that's where a tornado would be within a squall line. But QLCS thunderstorms aren't the only squall lines or systems that we get in Indiana. We also have derechos. And in fact, honestly, derechos are more worrisome than tornadoes because of how widespread they are. These things are windbag producing machines. The one picture there is a 2012 derecho. Many of us remember that one. This thing had winds between 80 and 100 miles per hour, with winds over 70 miles per hour recorded at Fort Wayne International Airport, which that record was not broken until 2023. So held for a long time. This is June 29th, 2012, the famous Midwest Ohio Valley derecho. This derecho traveled 450 miles in under 7 hours. In 6 hours, it went 450 miles. Average speed was 75 miles an hour. Again, that's how fast we drive on the freeway. And that's how fast this thing was moving with winds of 80 to 100 miles an hour. So imagine a windbag steamroller moving at freeway speeds, originating near Chicago, going all the way to Virginia. So these things are very, very powerful But to have a derecho, you have to have a certain criteria met. I know a lot of these thunderstorms, you have to have criteria or levels. A derecho is no exception to that. For a derecho to be termed a derecho, and a lot of times they aren't termed a derecho until days later, after all the data is analyzed, your damage assessments are done, and your wind speeds are analyzed as well. Is it then termed a derecho? But to have a derecho, you have to have winds greater than 58 miles per hour, with a few significant wind gusts in there too. 70-mile-per-hour reports have to be in there too. And it has to be causing damage for at least 240 miles or longer. Again, this one met that criteria by double. It went 450 miles in 6 hours with an average wind speed of 75 miles per hour, but had occasional wind gusts up to 100 miles per hour in 2012. So again, these are very, very powerful systems, and we get them frequently in Indiana. Indiana, a lot of people don't know, but we are in derecho alley in the United States. We average a derecho every year. We don't get them every year, but we average them quite often. Here's a map here of derecho frequency between 1980 and 2001. Now, I know this is going on 24 years ago, so we've added a few of these to these numbers here. But again, it gives you a really good depiction of where their frequency is. So we get them quite a bit out in the plains between Oklahoma, Kansas, Missouri, and Arkansas. But look at the much larger spread there. 27, 27, 24. Illinois, Indiana, and Ohio, and southern Michigan, and Wisconsin. We are in derecho alley here in the United States. A lot of times what we have up in the northern tier of the plains are called a progressive derecho. We'll talk about that here in a little bit. A lot of times these are your longer lived derecho events versus down here in the south. These travel much larger distances at times here in the Midwest. Again, we typically see our derechos in May through July. Our summertime months is when we most commonly see them. And in Indiana, June is when we see them the most. Across the United States, they're most common in May, June, and July. You can see 22% of them happen in May, 20% in June, and 21% in July. A lot of that has to do with the setups that we get that time of year. A lot of times in the summertime, we get heat waves, right? As an area of high pressure moves in, we're hot, we're wishing it's wintertime, we're 85 degrees, we're sweating, it smells like corn outside. It's just miserable, right? We're all inside at work with the AC turned on, wishing we had a pool. It's hot. But on the northern end of that, we have a really tight pressure gradient stretched across the northern tier of the United States. We have a colder air mass over Canada. We have a tight pressure gradient there. And storm systems love to ride on that pressure gradient. They love to ride the edge of the high pressure. The high pressure pushes them to the north, and they ride right along that pressure gradient there. This is why we have progressive derechos here across Indiana, because they are progressive in nature. They progress over a large area versus what we have in the plains. Notice the pressure gradient over where it says serial derechos. Notice how that's a tall oval versus a stretched out oval. A lot of times the high pressure, will dissolve them before they get into eastern Oklahoma and Arkansas. They do their thing over Colorado, Kansas, and western Oklahoma, and then they'll fizzle out and they'll die. Versus when you're on the northern end of the high pressure, you can see your lines of pressure there. Your millibars are stretched out. They're linear. When that happens is it gives more time for your derecho to travel, intensify, and traverse longer distances. So that's another reason why we have progressive derechos here in Indiana. They are most common in June here in Indiana, is when we typically see these, heat waves start to move in. We start to see that ridge of high pressure build, weaken, and build again. And derechos usually follow a heat wave or other blocking pattern here in Indiana. So again, we are in derecho alley here in Indiana, in the United States. And now we get to the supercells. I know this is what everybody in here wants to talk about. Everybody goes to these trainings to talk about tornadoes, right? Well, here we are. You've made it. Supercells are common here in Indiana. We do get them every single year. Now, it takes a lot of moving parts, a lot more ingredients to get a supercell than it does in ordinary cell thunderstorms. These are your big boys, right? This is your garden variety thunderstorm on steroids, right? It has a lot more to work with, a lot more energy, and these are often a lot more long-lived too. So to have a supercell, you have to have a rotating updraft. That's what makes a supercell a supercell. You have to have that rotating updraft. And what that allows, it allows the storm to remain a thunderstorm so much longer. It allows it to sustain itself a lot longer. It allows the hazards to be presented a lot longer as well. So these are very dangerous storms. Supercells do occur in Indiana every single year. We have them here. Now, they range between size and intensity, but they do happen here in Indiana fairly frequently in the summertime and spring months. They can produce extremely large hail. Think anywhere between quarters to baseballs. That's what these big boys do, occasionally larger than that. These can have damaging winds and tornadoes associated with them as well. However, not all supercells. I know a lot of times people think supercells, they think automatically tornadoes, when in fact that's not the case. In fact, only 20 to 30% of all supercells across the entire world actually go on to produce tornadoes. So in fact, tornadoes are actually a very rare occurrence anywhere in the world, including the United States. It takes a lot of moving parts to actually have a tornado even happen. It's a wonder the tornadoes even happen at all, just between of how many things have to come together at the right time, the right amounts to even have a tornado happen at all. So they're actually very rare when you think about the long term and the big picture of how many supercells we have compared to how many produce tornadoes. One of the ingredients, and probably one of the most important ingredients to have a tornado or a rotating updraft at all, is you have to have wind shear. Wind shear is defined as changes in wind speed and direction with height. So as you see on the left, this is our speed shear. Wind increases in velocity with height. So the higher you're up, the faster those winds are moving. This really helps get our updraft tilted. That is a key part of what makes a supercell. We have to have our tilted updraft. This allows it to feed on that warm, moist air. A lot of times, ordinary thunderstorms die out because they get choked out on themselves. Their rain-cooled air, or their downdraft, is situated right where their updraft is. Their updraft isn't tilted. We don't have a wind shear. It's just a heat bubble that rises and it rains and it dissipates. When we have a severe thunderstorm, in this case a supercell, think of an ordinary cell thunderstorm that tilts at a 45-degree angle. Now our updraft is in a rain-free base. We have a lot more ingredients to work with, and it's not dying on its own exhaust. So we have a lot more going for it. And that's where our changes in wind speed and direction come from. We have directional shear as well during supercells. This really helps the storm scale process and allows the updraft to rotate. Again, speed shear is only part of the equation. We need directional shear too. A lot of times we need winds changing at different directions with height. This is termed vorticity. We need that in the atmosphere. We need a lot of spin. This helps our updrafts pick up on that and start to rotate. All rotation in the atmosphere actually starts out as a horizontal tube like you see there on the left. Only when a thunderstorm's updraft moves over that area of spin does the updraft pick it up and turn it from horizontal like a rolling pin into a vertical like a mixer. So that's how it works in the atmosphere. Now, tornadoes, like we said, only 20 to 30% of all supercells go on to produce tornadoes in Indiana. But tornadoes happen every year. We average 22 of them. But on occasion, they do cause damage, and we have to have a way to rate that tornado damage. Currently, we use the Enhanced Fujita scale. For those of you that don't know, this was designed by Dr. Ted Fujita. He revised this scale in the early 2000s. This really, excuse me. It's based on tornado damage. Contrary to popular belief, a lot of people think tornadoes are automatically rated by their wind speed. It had 180 tornado or 180 miles an hour. F4 had to be F4, right? But that's not the case. Tornadoes are rated on a scale of 0 to 5. Here in Indiana, our most common tornadoes are EF0s, EF1s, and maybe a few EF2s. We rarely see EF3, EF4, and EF5. However, that is all determined based after the fact. We only rate tornadoes after they happen because it's a damage scale. After a tornado occurs, the National Weather Service will work with local emergency management, local engineers, and they'll go and look at the structures and the damage that was affected, whether it's tree damage, structural damage, and they'll work to determine how strong the tornado was that occurred. And then from there, they'll add a wind speed estimate later after they determine what the structures were weighted for. It's very interesting and how they go about that. A lot of times structural engineers will look at the building process of a structure that was destroyed. They'll look at things like, how were the stud walls built? Were they reinforced? Were they toe-nailed in? How well was it constructed? A lot of times people will see tornado damage and automatically assume, well, gosh, that had to have been an F5, when in reality it was an EF1. So a lot of that has to do with the type of structure affected, and just the damage points around that structure too. But here in Indiana, we average EF0, EF1, and EF2 tornadoes being the most common, but we can get bigger ones, and we do. Think last year, we had a very high-end EF3 tornado impact Winchester, Indiana, and that was almost an EF4. In fact, the National Weather Service was contemplating placing it as an EF4, and they teetered and tossed around that idea for some time. And the only reason that they did not, from what I know, and a lot of this goes back to the Taco Bell that was destroyed there. For those of you that don't know, there were actually occupants inside the Taco Bell. I believe they took shelter in the freezer as the tornado passed by, and they miraculously survived because there was nothing left of that Taco Bell but the floor. I mean, the entire structure is gone. If you were to look at that, one would think, well, that had to have been an F5, but yet it was only rated an EF3. And that comes down to the engineering process on how that Taco Bell was built. It was built unreinforced. Therefore, it made it easier for the tornado to destroy it. It came down to the micro engineering details of that structure to then be determined that, all right, maybe it didn't take as strong winds to destroy it as what was previously thought. So a lot of thought and a lot of consideration goes into that damage survey when the meteorologist and the damage survey team go out. So a lot of behind the scenes there that goes on when rating tornadoes. But we can get strong tornadoes here in Indiana. So that concludes our, now we're going to start talking about storm safety here in Indiana. As this is Severe Weather Preparedness Week, it started yesterday and runs through the weekend. This is a very important time of year to start talking with your families, your businesses. Where do you go when severe weather happens? A very common question. A lot of times you don't think it'll impact you until it's too late, and it does. So you need to be able to practice, monitor, and then take action. Be ready for these. These are 3 steps that you need to follow, not just this week, but all year round. Again, we can get severe weather any day in any month here in Indiana and across the Great Lakes region as a whole. So these 3 steps can help you out along the way. The first one being practice. Know where your safe space is and practice drills. Do that with your business, your home, no matter where you're at. Know where to go in the event of severe weather, whether it's, severe thunderstorm warning, tornado warning. Know what to do and have a plan of action. That way, in the event a warning is issued, you already know where to go. It's routine for you. That's where we want to be at this year. Don't become a statistic, whether it's injury or fatality. Become a statistic that you survived. That's really what it comes down to. You got the warning, you took action, you knew where to go. That makes a meteorologist's day. Just go ask them. If they know that you did this and you followed the steps, that'll make their day. I promise you. Monitor the situation. A lot of times in the event of severe weather, there'll be warning days. You'll know ahead of time. Hey, let's say it's Sunday and Tuesday. Hey, there might be a chance of severe weather. All right, now we need to monitor that. Stay up to date on the weather information and be ready for alerts. A severe thunderstorm watch is issued at 12 o'clock and it goes till 9 p.m. Okay, let's monitor that. Be ready to take action if it comes to that. And that leads us to the final step. Take action. Seek shelter when severe weather strikes and wait for the all clear. The most dangerous part, and I tell you this from experience, the most dangerous part is actually after the storm has passed. Wait for the all clear is extremely important when it comes to severe weather. Wait for that all clear. Make sure all threats are over before you come out and it is safe to do so. When severe weather strikes, it's extremely important to be cautious, especially during tornadoes or high wind events. You have down power lines when you come out. You have debris everywhere, nails, insulation, a lot of sharp objects that you don't want to step on or be near. So again, it's very good to wait for the all clear and know that it is safe to come out. Now, a lot of you, when you practice your drills, you need to make sure you know where to go. Where do you go during a tornado or severe weather? This is a question we get asked frequently, and it needs addressed. Know where to go is very important, especially when sheltering from a tornado. Upstairs, not a good idea. Again, Winds increase where? Well, they don't increase on the ground. They increase with height. So the higher you go, the faster those winds are going. So not a good idea to be upstairs. So thinking you need to go upstairs to look for this thing is not a good idea. You need to go downstairs. So exterior walls, not a good idea. Again, if you're in an average home or even an apartment complex, go to interior room, whether that's a hallway, a stairwell. Put as many walls between you and the outside as possible. Tornadoes do their damage from the outside in. That's how they eat. They eat your home from the outside in. So putting yourself with as many walls between the outside and you will increase your chances of survival and staying safe in the event of severe weather, including a tornado. Again, basements are always your best bet. Anywhere in a basement is safe. Anywhere underground really is safe. But if you don't have a basement, and many of us don't, again, find that interior room. And then we also get the question, well, I'm in a prefab home, I'm in a trailer, same thing applies. In the event of severe weather for you, this is where it comes back to practice, especially for those of you in RVs, prefabricated homes. Knowing where to go is essential, especially essential for you, because nowhere, and I repeat that, nowhere is safe in a trailer or prefabricated home in the event of severe weather, and especially a tornado. Again, so many injuries and deaths occur in those prefabricated homes from people who did not take action. They waited it out. And that is so dangerous to do when really all you had to do was practice. Practice and know where to go. Have that stronger structure in mind that you can drive to or go to in the event of severe weather. Waiting it out in your camper or mobile home is never a good option. Wind can get underneath, they can roll, trees can fall right through them. They're very weak structures. So having a place in mind, and I say this with a tender heart as well, having been on scenes of those areas after severe weather, having a place in mind already picked out, that way you and your family know where to go in the event of severe weather. And again, I know our average lead time last year was 13 minutes. But severe weather doesn't always give you a lead time. It can be from 0 to 13 minutes, but you should always treat it as seconds to minutes. As soon as that tornado warning is issued, especially if you're in an RV park, have that tornado shelter in mind, have that friend in mind, have that stronger structure in mind within distance so that you can go to it and take shelter. Again, very crucial during events of severe weather. And another thing, especially a lot of motorists ask us, well, what if I'm on the road when a tornado warning is issued? Like, where do I go? What do I do? It's a very important question and a valid question. I know a lot of us travel. A lot of us have places to go. I get it. Life happens. If you're on the road, get off the road if you can. If you are near an exit with a stronger building, whether that be a rest stop, a restaurant, even somebody's house, go knock on the door. I know if there's a tornado warning, I would let a stranger into my house to shelter. I mean, it's courtesy. So try to do that if you can. That's always your best bet. Try to find a stronger structure, a well-built structure to go into and ride it out. That's your best option. What not to do is seek refuge in your vehicle, outside or under an overpass. Again, overpasses are terrible ideas. Those of you that have watched the movie Twister know what I'm talking about. That is an accurate depiction of what will happen if you shelter under an overpass during a tornado. Winds actually get amplified. Think of it like an airplane wing. Air pressure increases in an airplane wing, allowing it to fly. Well, that same thing happens under the overpass. The wind is amplified. It is squeezed underneath, and that'll suck you out. It creates a vacuum. That'll suck you out no matter where you're at. Terrible idea under an overpass. Again, it's the worst place to be in the event of a tornado. Do not seek shelter under an overpass or even a tree. A tree is a terrible idea. It can shield you from the rain, but if it falls, it can crush you or your car. It's a terrible idea. So your best bet is to pull over, try to find a sturdy structure to go to, and just ride it out. That's really what you need to do in the event you're on the road. Our last thing we need to talk about here are outdoor warning sirens. Again, many of us heard them today at 10:15 a.m. Across the state. Many towns and municipalities sounded them. I know there were some issues in Indianapolis, but our wonderful gentlemen there at the EMA and city officials are working on figuring out what happened there. That way, in the event of severe weather, they will sound. But sirens are designed to warn those who are outdoors and are not meant to wake you up inside. I know a lot of times during severe weather, people like to wait on the tornado sirens. Not a good idea. They were never designed to wake you up inside your home. This is why we say we need multiple ways to receive warnings. We don't say that just for the heck of it. We say that because we mean it. Have your cell phone next to your bed with alarms turned on. That way it'll go off when the emergency alert system is issued. You'll get that alarm sound on your phone. The same alarm sound, whether it's an Amber Alert, whether it's a tornado warning, it will sound on your phone. NOAA weather radios, very important tools to have. If you don't know, comment after this and I'll send you the link. Midland is who I recommend for that. Wonderful, wonderful products with them. NOAA weather radios are a great way to have with you and your family, and a lot of them are battery operated too. I know a lot of times in severe weather we lose power. That's a great tool to have to make sure it's the all clear, waiting, knowing that it's clear to come out. Great tools to have. But when you're outside, let's say it's a beautiful afternoon. A lot of times our severe weather events start out nice here in Indiana, Morning rain has moved out. It's sunny now. It's warm. The birds are chirping. We want to go play golf, right? We're out on the golf course, smacking a few balls. But then, the sirens go off. What do you do? When you hear a siren, you are to immediately seek shelter indoors and seek additional information. Find shelter, right? Same thing if you're on the road, but this time you're outside. Seek shelter inside a sturdy structure. As long as it's not a prefabricated home, go inside, interior room, hallway, stairwell. Bathrooms are great. Do not assume the threat is over. And again, this is very important. Do not assume the threat is ended when or if the sirens stop sounding. Sometimes tornado sirens do stop. Sometimes there's limiters on them. Sometimes they do stop or power goes out. Sometimes they're not on battery backup or generator backup. Sometimes they do stop sounding. Do not automatically assume the threat is over when you don't hear the sirens. That is what that emergency alert system is for. NOAA weather radio and multimedia broadcast media alerts are for. Again, multiple ways to receive warnings, not just to receive warnings, but also to receive the all clear. Knowing your location to proximity of where the storm at and what broadcast meteorologists are telling you are very important during severe weather events. So with that being said, I know we kind of talked through a fire hose here tonight, so I hope I didn't lose anybody. Kind of turn to the comments here real quick before we do a quick recap, and then we'll go into a pop quiz as well. Again, we got Julie in here, Freedom in here, Emmanuel's in here, Lori, Trent. Great to see you guys. So with that being said, we'll go ahead and keep on a rolling here. This is where it gets fun. So I do need some interaction with this point, so don't be shy. Turn on your comments. I do need you to respond here, and we'll have fun with this. All right, so with all of your knowledge of severe weather, and it's time to test your knowledge on how much you know. Again, it's not hard, I promise. I'm not going to make fun of you or anything like that. This is why we do these things. So weather identification. This was honestly my favorite part of this entire class. It's a great way to familiarize yourself and a great way to have a good time as well. So is this a tornado? Again, put your answer in the comments. Is this a tornado? And if it's not, put your answer in and tell me why. We got Julie. Julie says it's a scud cloud. Yeah, maybe. Summer says no. A lot of you guys are saying no, but can anybody tell me why? I'd love to know that answer. If you guys know why, that'd be great. Again, Summer says no. Trent says no. Freedom says scud. It's not a hurricane, I promise. That's one thing we don't get in Indiana. If we were in Florida, we would talk about that in our Severe Weather Preparedness Week. But here in Indiana, we don't have to talk about them, which is great. Freedom says no rotation. Very good. So, yeah, this is a scud cloud. This is the #1 cloud to get misidentified as a tornado. So many false reports come from these guys. They look scary. I mean, look at this thing. To the untrained eye, it may look like a tornado. It's a cloud, and it looks like it's touching the ground, right? But look at the edges. It's jagged. It's not smooth. And there's no debris at the bottom. A lot of times in a tornado, you'll see dirt getting kicked up, sticks, leaves, debris. There's none of that here. Scud clouds are nothing more than moisture that has condensed into a cloud, and they'll dangle there and just move with the cloud. A lot of times they'll rise into the cloud as well. Yeah, Julie says SLCs, scary looking clouds. Yeah, that's really what they are. They're ominous. They look scary, but they're harmless. They're nothing more than moisture. Like, think of it like you take a shower and you have steam rising. It's the same thing here. So just moisture rising into the cloud is all this is. So those of you nailed that one. So I'm sure I have a lot of faith in you guys nailing this one. Is this a tornado? And tell me why. What's different between this picture and the one we saw before? Again, the one before had ragged edges. Okay, that's a big hint there. Ragged edges. But what do you notice about this one that's different than the one we saw before? So Freedom says, yes, this is a tornado. All right. Now, can you tell me why? Why is this a tornado and not the first one? Because, again, this is a still frame picture. You know, we can't see by this picture it's rotating, right? It's a still frame. What are some indicators that we can see from this picture that for sure says it's a tornado and not a scud cloud? You know, what do you guys see?
I want to point out as well, we have a second funnel at least in the right side of this image.
Yeah, there's even a satellite funnel in this picture as well. They can happen. A lot of turbulence going on. Very, very good answers here. Man, we got a smart crew here tonight, Ryan. I tell you what, Indiana is set. All right. Yeah, Casey says, yeah, more rotation in the clouds and lower into the ground. Yeah, you can see that there. You can actually kind of pick out your wall cloud there, right? Summer says smooth and the rotation at the top of the cloud. Yeah, smooth. That's one of the indicator words I was looking for. Smooth, right? Due to the rotation of the funnel cloud, a lot of times they appear smooth, right? There's a tight pressure gradient there. Pressure is increasing, pressure is dropping, and as it's dropping, that condensation funnel comes all the way to the ground, and a lot of times it's smooth. Versus a scud cloud, no rotation, it's just moisture rising, so we get a lot of ragged edges. It's just dangling there, right? Like a loose tooth. It's just dangling there. Versus a tornado, it's smooth, it's cylindrical, it's tight. But what's something else that you see here? So the one on the right is a funnel cloud, right? We can't confirm something that we can confirm something with the one on the left. What is that? What can we confirm with the one on the left that we cannot confirm with the one on the right? There's something that we can see with the one on the left that we cannot see with the one on the right. Does anybody know what that is? Why can we call the one on the left a tornado, but the one on the right a funnel cloud, and we cannot definitively call it a tornado? Why is that? Does anybody know? Again, very important here, and something that a lot of times we as spotters or chasers have to know before we talk to the radar operator at the National Weather Service. They want to know these things too. What is the one on the left doing that the one on the right is not? Trent got it. All right, there we go. Bonus points. I don't have any prizes, but you get a pat on the back. So Trent says the one on the left is on the ground, bringing dust up. The dark gray stuff surrounding it. There you go. That is what I was looking for. Debris, right? A tornado cannot be classified or termed a tornado until we have definitive rotation on the ground, right? That rotation has to make contact. We have to have that debris signature on the ground. It has to be causing damage to be a tornado. Otherwise, it is just a funnel cloud. So that brings up a really good point, though. Here we have an open field. We can clearly see the debris. We can see the dust getting kicked up. The one on the right, we can't see that, so we can't call it a tornado. It's a funnel cloud. So what if, let's say there's a woods in front of our funnel cloud or a tornado, and we can't see the debris? You know, that would still be considered a funnel cloud until we have a really good visual ID that we can definitively say it's made contact with the ground. We have a tornado in progress. Very, very important things here. But nonetheless, if you see any one of these things happening near or nearby, this is something that we go back to, back to this slide here, tornado radar indicated, tornado observed, any of these, you need to be in your safe place, right? Whether you see a funnel cloud or a tornado, I don't want you guys taking pictures. You guys need to be in your safe place, right? So very, very good. You guys nailed it. I knew you would. See, this is easy, guys. I mean, I don't know why you're sweating in the background thinking this is a test. I mean, come on. It's easy. All right. Here's where we get fun. This is where you guys need to have your Sherlock Holmes magnifying glasses out. Here's where we're going to play think of it like, oh, I'm losing the word, but you get to play detective here, right? So what caused this damage, right? This is a tricky one. So this can actually have a couple answers here, but there's really one that I'm looking for here. So to give you the backstory, this is late May here in northern Indiana. A big thunderstorm had just moved through, and this was a cornfield here. The corn, a few hours before this photo was taken, was actually 2.5 foot tall, mind you, and now it has been reduced to mere inches. So this field was a total loss. It was replanted and everything was good. So this end of the story has a good ending, but this is not good in the moment here. All right, I see a few answers for B. Hail. Can anybody tell me why? Why do you think it's hail versus like not a flood? I mean, I see some water there. Why do you think it's hail versus, you know, a tornado, flood, wind, you know? CD-sized hail, yeah, maybe. This is where we start to talk about our forensics meteorology, right? Forensics was the word I was looking for. What are something that you see here? What damage indicators do you see here that would make you sway, you know, hail versus flood or tornado? You know, this is where a lot of times when the National Weather Service, so you're now on the damage survey team, this is what the meteorologists and engineers are looking at when they determine what caused the damage, right? It's a lot of forensics meteorology, right? What caused this to happen? Think of it like you're on a murder scene, right? Everybody likes murder shows on TV. You know, you see your forensic, you know, anthropologist or whatever, you know, saying, all right, how did he get shot and where, right? Well, what happened to this cornfield that caused it to look like this? Because I can guarantee you 10 hours ago, it did not look like this. So, all right, we see some answers coming in here. Broken stems, Frito says. Ding, ding, ding. Thank you, thank you, thank you. Again, forensics is very important here. And this is kind of, and the reason we do this is to kind of show you behind the scenes on how much goes on behind the scenes. You know, we can't just rate something by radar, right? There has to be boots on the ground and we have to look at what's going on. Yeah, this corn got shredded. It just got absolutely shredded. And hail is actually the correct answer here. Lots of hail. This storm actually produced 2 to 3 inches of hail between pea-sized and quarter size. So a very intense thunderstorm here. So yeah, this cornfield was shredded by hail. So we have a couple more here. What caused this one? This is the one that gets a lot of people. Everybody automatically assumes something that it's not when they see damage like this. So we'll go ahead and let you answer here. But there's a couple key things I want you to look at here when you answer. Again, forensics meteorology, right? You're on the damage survey team. You're assessing this damage. What happened? Julie says straight line winds or C. Janine says C, wind. All right, yeah, could be. I mean, the trees obviously got blown over, right? So there had to be something come through here, right? I mean, trees don't just fall over for nothing. Can anybody tell me, all right, a lot of you guys are answering wind, but can you tell me why it's wind and not a tornado? I mean, tornadoes blow trees over too, right? They cause a lot of damage. Why is it wind and not a tornado? Anybody know? Again, these are things the damage survey team will look at in determining, you know, what happened. Look at the 2 trees here. I'll give you a hint. Look at the 2 trees here. The one just to the left of the logo, and then the one right next to the letter B there. What direction are they laying in? Yeah. It's in a linear straight pattern. Yeah, exactly right. This is straight line winds. Straight line winds are like a steamroller. The wind's going in one direction, and it'll lay everything flat in that direction as it goes. So very good. This is straight line winds, not a tornado. I can't tell you how many times I've heard people say, oh, it had to have been a tornado. I mean, it just had to have been. Well, not necessarily. Straight line winds can cause very similar damage to that of a tornado. Again, look at our duration in 2012, up to 100 miles an hour. That's the same as an EF1, EF2 tornado, but straight line winds, right? But it wasn't a tornado. So straight line winds can cause very serious damage. Now, what about this one? You know what caused this one, right? All right, similar damage. All right, we got some sheet metal there, some trees blown over. You know, use your damage words, right? Your indicator words, right? What are some indicators here that might indicate, you know, it's one versus the other? You know, what are we seeing here that we didn't see in the last photo? Julie says tornado. Yeah, Could be. I mean, we obviously had some wind, right? I mean, we had to have had some wind. Summer says tornado. Yeah, could be. I mean, we know it got windy, right? It blew some trees over, some limbs are down. Obviously have maybe some roofing material there, right? Looks like chaos. Yeah, it's a little chaotic there, especially there on the bridge there. Yeah. Freedom squinting. Yeah. Squint if you need to. Look for those damage indicators. You know what is in straight line winds? The winds are pushed down, right? There's no lofting, so that's a big hint there. What picks stuff up versus pushes it down and blows it around? There we go. Summer has the key answer I was looking for. Debris isn't in the same directions from what I can tell. Very, very good. That's the key difference between straight line winds and a tornado. Again, straight line winds blow stuff down in what? The same direction, right? A tornado has convergence and divergence. We have debris everywhere. We have debris weighing one way and another way, and we also have lofted debris, right? There's an updraft there. Straight line winds do not have an updraft. Everything's pushing down and away. And a tornado, it's lifting up and sucking up as it's blowing everything around, right? So it obviously picked up a roof. It threw some objects. But look on the limb here. I'm going to point you to the limb. So look at the end of the guardrail. I'll point you to something here. You see the caution sign there. You go up about 2 to 3 inches. You'll see a piece of tin in the tree, right? We have some lofting debris, right? This debris wasn't blown down. It was lifted. It was lifted off the roof and blown into the tree. So that's why this is considered a tornado. So you guys nailed this. I mean, I knew you would. I really did. So no reason to sweat, right? Got a couple true or false questions here to test your knowledge here before we end today. Does lightning make a storm severe? True or false? You know, put your answer in. I want to know. Again, a lot of people don't know. So this is why we do this here. Now, lightning is dangerous, whether it's severe or not, but doesn't make it a severe thunderstorm. Julie says false. Anybody else? Does anybody else know? It's okay if you don't know. That's why we do these things. Again, no judgment here. So Trent says no. All right. Summer says no. Yeah, you guys got it. Lightning does not make a storm severe, but it is dangerous in and of itself. I mean, it's burning way hotter than the sun. It'll vaporize anything it strikes. It can blow tree bark, tens of feet away from a tree, if not explode the tree and knock it over. So, I mean, it's very dangerous. So, yeah, lightning is very dangerous. On average, it kills people every year in the United States. It can start wildfires. It's very dangerous, but it does not make a storm severe. But when thunder roars, go indoors, just because it can be dangerous. It can kill people. So, yep, you guys nailed that one. So going back to our knowledge on what makes a severe thunderstorm severe, is 55 miles per hour and dime-sized hail a severe thunderstorm? Like is it? What do you guys remember from what we talked about, from what makes a severe thunderstorm warning a severe thunderstorm warning? Does 55 and dime make a severe thunderstorm severe? Julie says false. I think it's 58. Yeah, could be. Maybe. We'll find out here in a minute. Get a couple more answers here, and then we'll tell you. If you don't know, that's okay. Just simply put, I don't know. That's fine. This is why, again, this is why we do these things here. Janae says yes. Yeah, could be. Summer says false. I think it's 57. Trent says, I think it's 57 plus. All right, so we get a couple different answers on this, and I wrote this on purpose to stump you guys, right? So 55 is close, but it's not a severe thunderstorm. Dime-sized hail is close, but it's not a severe thunderstorm. To have that criteria, we need quarters, which is 1 inch or larger, and we need 58 or greater to be a severe thunderstorm warning. So again, I put this in there to trick you guys on purpose, just to test your knowledge, but this is why we do these things. You guys are really close. And I do have one thing to show you here on a video here to show you what a lot of people automatically assume. So you guys, I'm going to play this video, and you guys are going to put in the comments how fast you think these winds are. And I put this in here as a good visual representation as, a lot of people, everyone's really bad at guesstimating how strong the winds are, right? And the reason for that, it's invisible. It's an invisible factor. We can feel it, we can hear it, but without debris, we can't see it. So I'm going to play this here. Right? I'll play it one more time for you. Again, take a look at that. Watch the rain. You can see the gust front come through. The trees are blown. All right, put a few more comments in here. Robert says 40. Derek says 50 knots. Yeah, could be. Janae says 90. Trent says 40 to 45. Yeah, good guesses. Freedom says 40 to 60. That's quite a range there. Yeah, could be. Summer says 45. Julie says I'll fail this. That's super windy when it's like 15 miles an hour. Yeah, good, honest answer. I mean, everyone, everyone's, I'll be honest, we are really bad at guessing winds. And that's not to point anybody out. It's just we are. It's an invisible factor. We can't see it. We can feel it. We can hear it. But without debris in the air, we can't really judge how fast it's moving. So that's why we put that in there. So that video was actually confirmed at only 35 miles an hour. That was a 35 miles per hour gust front. Not 45, but 35. That was only 35 miles an hour. But it was light wind events. A lot of people think, well, why didn't I get a severe thunderstorm warning? The wind was a ripping, the trees were blowing, Where was my warning at? Well, chances are, maybe it wasn't severe criteria. That was only 35. If that was severe criteria, everything would have been white, right? Those trees wouldn't have been just blowing or moving back and forth at the top. They would have been leaning over, right? So the stronger you go, the louder it gets, and the harder it becomes to see, too, when you're in that situation. The rain is just blowing exponentially harder. So that's why we put that in there. Not to trick you guys, but to show you guys, just how bad we are at guessing winds. But it's important we show you that. So we have one more question here, and then we're going to go in the Q&A and try to have a few minutes here to answer your questions here. So what do you do? Again, this is very important. If a tornado warning is issued, I don't know why I put you in there. It's a typo. I was making this late last night. Again, if a tornado warning is issued, where do you go? What do you do? Where do you go? If there is one takeaway here tonight, this is something I want you to take away. What do you do in the event of tornado warning? When seconds count, minutes count, what do you do? Where do you go? Yeah, you guys nailed this. The answer is always A, not B, not C, not be Hillbilly Fred and go out and take a picture of it. No, go inside. Bathrooms are great. Basements are always a first. Again, it doesn't matter where you're at. Always have a safe plan in place. Again, that's the number one takeaway here tonight is anticipate, plan, and then take action, right? If we don't take away anything else from this severe weather workshop, make sure we have a way to, plan, prepare, and take action. Practice, monitor, take action. If there's not a takeaway tonight, this is the takeaway I want you to take home. And this is why Indiana has a statewide severe weather preparedness week this week, is because we get severe weather a lot of times in March. We've had tornado outbreaks the last 2 years in a row in March. March 14th of last year and March 31st the year before. Severe weather is not uncommon in the state of Indiana. And in fact, it happens in March very often. So this is very important for you to take away here tonight. Practice this with your family. Know where your safe place is, whether that's another structure, another building. If you're in a prefab home, if you're in your own home or an apartment, maybe that's a stairwell, a bathroom, a basement, a laundry room. You know where that safe place is and how to get there. And it's up to you to pass that along to you and your family, or any children you may have, or friends, or even neighbors. Let your neighbors know well, right? Communication is very important in terms of severe weather. So knowing where to go ahead of time, monitoring that information, and being ready to take action when action is needed is key, right? That is the main takeaway here tonight above anything else. Practice, monitor, take action, right? Knowing what to do, where to go in the event of severe weather. So with that being said here, guys, it's 8:30 or almost 8:40. Went a little long, but that's okay. We had some great interaction, great comments. We'll stay on here for maybe 5 to 10 more minutes here to answer any questions you may have. And before you answer the elephant in the room, we are watching the system for this upcoming weekend. We may have an early preliminary forecast out tomorrow. A lot of that has to deal with what data comes in tonight. Again, this system or this piece of energy is moving onshore right now across the Pacific. So as it moves onshore, it'll get analyzed by balloon launches, aircraft, and all those data points will get entered into algorithms and then put into our forecast guidance. So our forecast models have to analyze that data and then in turn interpret that data. So as that data gets interpreted, we'll analyze that, and we'll try to have forecasts out here over the next day or two on that system. But right now, some thunderstorms are possible late week. Severe weather, we'll have to keep monitoring that. It's not out of the question. I think severe weather is possible across Indiana this weekend, but we won't know to what extent or to what severity until we have more data and have that available. So we will post those forecasts if need be. But if we have any other questions on severe weather preparedness, Ryan's on here too. He's in the background, but we'll be happy to answer those for you here over the next few minutes here. And again, thanks for joining us. Much appreciated your participation tonight. Again, if I could give all of you guys a participation trophy or a sticker or something to take away, I would. It's been awesome hanging out here with you guys on this Tuesday evening. So Summer asked a question here earlier about taking shelter. What if you were in the middle of nowhere and driving and can't find a shelter? Would a low-lying ditch be good? That is a great question. And as a storm chaser, we try not to put ourselves in that situation, but that situation is a real risk. I mean, it really is. Sometimes you're in the middle of nowhere. And honestly, the best answer I would have, I've always been told, don't be afraid to ditch. I know it sounds really bad. I mean, none of your options are great at that point in time. If you can get out of the way of the tornado, that's your best bet. A lot of times tornadoes move east, northeast. So if you can get south, that's great. But if you can't see the tornado or don't know where the tornado is moving, don't attempt to outrun it because chances are you can't. If you can find a culvert, a ditch, don't be afraid to ditch. In the event of a strong tornado, tornadoes can lift cars and roll cars. So being in your car is very dangerous. If that absolutely worst case scenario came into fruition, and I pray to God it doesn't for anybody, just because it's a terrible situation, I wouldn't hesitate to find a ditch or a culvert. If you lay flat, right, not allowing air to get underneath of you, chances are the wind velocity of the tornado is so fast it doesn't have time to get into the ditch and scoop you up. So if you're laying as flat as you can, hands over your head, protecting your head from debris, but if you're laying in a deep enough ditch and you have, 2 or 3 inches above your back, chances are the wind will not have time to scoop you up, right? That's the worst case scenario, best case outcome, right? It's not really a good outcome no matter where you're at, but I would rather you do that than go under an overpass, go up near the girders, right? Like you see in the movie Twister, right? That's a terrible idea. Just like in the movie Twister, you will get sucked out under an overpass. That was not Hollywood. That was not far-fetched in that movie. There were some Hollywood moments in that movie, but that was not one of them. That was actually depicted very accurate, and it was meant to scare you, right? Do not, under any circumstance, take cover over an overpass. That's takeaway number 2 tonight, right? I don't want to see any of you guys taking shelter in an overpass. If I see you, I will reprimand you for it, right? Do not do that. But that's what I would do if you're in that situation. Again, I mean, it's a horrible situation no matter where you're at, but that's what I would do personally. So I hope that answers your question a little bit. Freedom asks, if one observes what could be a microburst or macroburst, but cannot tell, what Would a downburst be acceptable if reporting to NBS? Yeah, so really the best way to do about that is report any damage they cause, right? Your radar operators at the National Weather Service, whether that's Indianapolis, Wilmington, Indiana has a lot of different offices working together to protect the state as a whole, right? The main two being Indianapolis and Northern Indiana, right? Our radar operators love it when you tell them time, event, location. They like to preach the tell method, and that is what I'm going to tell you tonight, right? So in the event of a microburst, chances are that microburst is causing damage. They would love to know that so they can record that. If you take note of the damage, a lot of times that'll be in the form of straight line winds. Microbursts are wind makers. It's a rain bomb, right? Your heavy downdraft comes down, it disperses in all directions, knocking trees down, limbs down. Take note of that. If you report it, remember to do the tell method, time, event, location. If you don't know the exact time, that's okay. Give them your location, a rough estimate, and they'll go back on radar and they'll track your location and they'll get that. And they'll just say estimated via radar. But be very noteworthy of how you report it, right? Don't embellish anything. Don't say what it's not. Just tell it like it is, right? We have too much limbs down. They're healthy, right? They like to know if the trees are dead or dead limbs or live winds, right? Typically, it takes less wind to blow down dead stuff than it does live stuff, right? So make note of that. Let them know that. We have 2-inch live limbs down, right? That's a key detail, right? Remember our indicator words, right, that we talked about during the damage assessment, right? We have shingles blown off, stuff like that. Just take notes of that, your time, event, location. Let them know if damage is occurring. But if you see, a rain shaft coming down with a rain foot, no, they don't need to know that. They don't need to know that it's raining somewhere. But if it's causing damage, that's what they're most interested in, right? When severe weather is active, our meteorologists are very, very hard at work. They're very stressed. They're very busy. Don't blow up their phone to tell them it's raining. Don't blow up their phone to tell them, lightning, struck in the field next to me. Now, if lightning causes damage, fire, telephone pole exploded, let them know. They'll mark that for damage. But don't just blow up their phone just to talk to them and tell them it's raining, right? They really don't like that. So I hope that answers your question there. So again, I don't see too many other questions here. Again, for this weekend, guys, again, like I said, the system's being sampled right now. We maybe have an early forecast out tomorrow, but we really won't know until more data is analyzed. We're still too far out. That piece of energy, our piece of energy for the weekend is just now coming on shore. There's a lot of data to be analyzed in real time to then put into forecasting algorithms for our guidance model. So we'll analyze that. We'll go through it. And at best, we'll have an early forecast or outlook, preliminary outlook issued tomorrow, but we can't guarantee that. We'll just have to see how data trends tonight. But again, this weekend, thunderstorms are possible, including severe weather. We can't rule it out this weekend. But again, we won't know to what extent, what hazards, until that data is analyzed and we know what kind of environment we have, how much moisture we have, how much instability we have, just what the setup is, and timing is very important too. Those are things we won't know until later. It's 8:45. We'll stay on here for about 5 more minutes here. But if you have any severe weather preparedness questions, we'll try to answer those here.
I have a good question here from Sam in chat asking what a good radar app we recommend. So personally speaking, and I think Caleb will agree with me as well, free weather apps are pretty bad in terms of radar. Mm-hmm. I would highly, highly recommend spending $10 and downloading an app like RadarScope. A RadarScope app is going to do you 10 times better. It gives you the wind velocity as well, so you can see there's rotation. It gives you a very basic understanding of the radar, from winds to rain to hail, all at the fingertips for $10. There's no subscription with that, and that's probably the best route you can go, bang for your buck. I really do not have a free weather app that has a good radar to my knowledge.
Yeah, and the biggest thing to add on that, a lot of weather apps offer something called future radar. That is what a lot of people get confused on, especially during severe weather events. Whether that's the National Weather Service, whether it's us calling for severe weather. Well, my app doesn't show anything until 4 o'clock, and you guys say noon to 5. Weather apps are AI driven a lot of times, so where they get their data matters. And a lot of times weather apps don't always get their data from the best source, and they're going to tell you something different at any time you look at it, or if you look at it now versus an hour, you're going to see different results no matter what, period. So be very mindful of that, that the weather is ever changing, ever evolving. And so take weather apps with a grain of salt. They'll get you close, but they're not perfect. But the best radar app for live radar would probably be Radar Scope. I do use Radar Omega as well. But when I'm out chasing, I probably use Radar Scope more, if I'm being honest. And that's just because of the reliability of the app and the functionality of it as well. So,
and also adding on to that, Radar Scope's gonna be your best option. That's cost effective because Radar Omega requires a subscription. So keep that in mind. Omega does have a lot more options like live cameras and stuff like that you can watch. So if you don't mind spending money per month, Omega is just as good as Radar Scope. But if you're looking for the bang for your buck, cost effective, go for Radar Scope.
If you're looking just for a radar app, Radar Scope is the best bang for your buck. If you don't want the additional features, if you just want radar, Radar Scope's the way to go, in my opinion. So any other questions you guys have here? Be on here for a few more minutes. It is going on 9 o'clock here, but happy to be on here. Happy to hang out with you guys. Still have quite a few of you guys in here, which is awesome. So again, we can go back and review anything if you need to. Now's your time to ask if we need to review anything. Don't hesitate before we hop off. So the main goal is tonight to be severe weather prepared. No matter what the severe weather is, Indiana is prone to severe weather in the United States. I know it's a lot of times it's not seen as being a part of Tornado Alley in the United States, but it very much is. We get tornadoes every year. We average 22. Last year we had 57. They may not be violent every year, but we do get them and they do pose a risk. We get derechos, we get QLCS systems, we get severe weather here. So being prepared and knowing what to do in the event of severe weather is very important. So if you guys have any questions on that, let us know. Skywarn classes, some are asked. Yeah, I can try to get you links. I know Northern Indiana and Indianapolis puts them on. I don't know how many they have in person this year versus virtual. I know virtual is a way they've gone over the last few years, especially since COVID when everything was virtual, right? But virtual has a way to reach a lot more people too. So if I can't find you the links, go to the actual National Weather Service's website, nwsnoaa.gov. Go to that, click on your local office, or just type in the National Weather Service, Indianapolis or Northern Indiana, wherever you're at. Type that in, and they'll have the links there for you to download to where you can see what location and when. I'll try to find that for you. If I can't, that's what I would do. So they'll have that there. Follow them on Facebook if you haven't. They'll post spotter updates as well. Again, they do their spotter updates in the spring. They're going on now, and they'll continue here over the next few weeks as well. Again, if you miss one, chances are they'll do a virtual that you can join in virtually and sit in from your home computer too. So don't feel bad if you miss your county's class, but they do virtual ones as well. So it's great. It's a great way to ask questions to the meteorologist. A lot of times representatives from that office will be there too, so you can ask them questions on how they operate and stuff like that too. So
Eric asked a question here. Can you speak on what you use for chasing? I missed pieces of that. Do you suggest Scope or Omega for more reliability? So reliability's sake, Radar Scope for sure. That's going to be your best tool in the field. As far as storm chasing equipment goes, it kind of varies chaser to chaser. You know, some people go out there with just a radar app and a camera. Some people just go out with nothing. You know, it just depends on the type of style. But typically speaking, GoPro, laptop, phone, anemometer to measure wind gusts.
I mean, personally, I use a variety of products between Radar Omega, GR2, Radar Scope. I use quite a bit. But I mean, another takeaway here tonight, you know, this is not a course to promote storm chasing. We can talk about that if you want to, but this is a severe weather preparedness course. I don't promote storm chasing, especially for those that don't know what they're doing. I may come across blunt to some people, but if you don't know what you're doing, you don't have any business being out there. I don't mean to be blunt, but I also don't like bad statistics. I don't like injuries. I come across too many when chasing, and I don't like to see them. So if we can prevent that, that's the way to go. But as far as what I use, though, again, I use a variety of products between Radar Scope, Omega, GR2. Really just whatever has the best coverage in the area I'm chasing is what I go with. So any other questions here? Again, if not, we'll hop off here. I don't see any. Again, the main takeaway here tonight, be severe weather prepared. I'm actually going to hit on this one more time just because of how important it is to me and to everyone here in the state of Indiana. Again, the main takeaway tonight, if you don't take away anything else, have a severe weather action plan for you and your family. Take the time to practice it. It's worth it. Too often I hear, well, I don't do anything because you're always false. Nothing ever happens in my house. Well, that may not be the case this year. It may be for somebody else, but not for you. So you should always treat it as if it's going to happen, right? Severe weather is never a matter of if, it's a matter of when. It really is. Sure, it can be sporadic sometimes, but it will eventually impact you to some degree. It's a matter of mathematical certainty. It's going to happen, right? We live in Indiana. We live in the Midwest. We get severe weather. It's going to happen, period, right? So making sure you are severe weather prepared means you're prepared, right? That is the key word. The key takeaway tonight is prepared. But you can't be prepared if you don't practice, monitor, or take action, right? That is all part of the word prepared. Being prepared means practice, knowing where your safe place is, whether that's in your home, whether that's in a stairwell in an apartment, whether that's another building, if you're in a trailer park or in a camper, if you're at a campground, right? A few years ago, we had a tornado go through a campground in southern Indiana. A very terrible situation, right? I would not want to be there. That'd be absolutely terrifying, right? Like, you're in a woods, there's trees everywhere, and you're in a camper. Like, you may as well camp in a cardboard box in a hurricane. I mean, it's just bad, right? So knowing where to go in the event of severe weather is key. Practice, right? Practice, practice, practice. Knowing where to go to the point where it becomes repetition. That's what you need to do. And then when we issue outlooks, right? Severe weather outlooks, they'll be issued by us. They'll be issued by the National Weather Service Storm Prediction Center. All of us have a common goal, which is we will increase wording when necessary, but we will also be very cautious as we do so. We want to make sure you get the proper warning without hyping it up. That way with certainty something's going to happen, right? We won't hype up our forecast unless we're absolutely certain that a risk warrants an upgrade, right? That's a little behind the scenes look on how we do stuff. But that's what monitoring is. If you see a risk a couple days out, keep it on your radar, monitor it, All right, so it's coming through, 5 to 10 p.m. All right, so it could come through before I go to bed or after the kids go to bed, right? Keep that in mind when you go through your plan. Here in Indiana, I'd have to say over 60% of our severe weather days are after dark. They happen at night here a lot. So this is where this becomes even more important. The severe weather risk always goes up at night. And a lot of that just because we can't see it, right? We absolutely can't see it. It's dark, it's raining, there's lightning, right? The threat always increases at night. And unfortunately, just where we are geographically and how everything climatologically comes together just so happens to be at night more often than not. It's really hard for us to get severe weather during the day in Indiana. More often than not, it's going to happen in the evening or early overnight. It's just how it is, right? We live in Indiana. So even more so to being able to practice, being able to go to your safe place in the middle of the night. You wake up, you automatically know where to go, right? So, and with that being said, have stuff to take with you, right? Always a good idea to have a flashlight. Chances are when severe weather comes, you may lose power. So when you come up, you're not going to be able to turn light switches on. So if you do have significant damage, have a flashlight. Knowing where to step is important. There may be sharp objects, nail, debris, power lines down, all things you want to avoid, especially power lines. If power line's down, don't go near it. Treat it as if it's always live unless told by an official that the line has absolutely been cut. Again, I can't express that enough. You don't get a second chance with those. You step on it wrong, you're dead. Chances are you're going into cardiac arrest and you're on the ground, period. So don't go near them. Very dangerous. Take action if a severe thunderstorm warning is issued or a tornado warning. No matter what the warning is, flash flood warnings. We get them here in Indiana. Rapid water rise, head to high ground. Do it. They don't issue those for no reason, right? There's a reason we issue warnings, and unfortunately it's because we've lost lives in the past. And we issue warnings for a reason, right? The National Weather Service issues warnings when there's a credible threat to life or property. So in turn, they want you to take action, right? That's why they issue warnings. If they issue warnings but nobody heeds them, nobody feels like they've done their job, right? So it's very, very important that you listen to them and you take action, right? So again, that's your main takeaway here tonight. I don't mean to scare anybody. That's not what this class is about. Hopefully, we don't have a bad severe weather season, but sometimes, unfortunately, we just have to be real sometimes, right? Severe weather isn't something we can always sugarcoat. It's bad, it's ugly, it happens. It has an ugly side of Mother Nature, and that's just the unfortunate reality of it. But the main takeaway is, have a plan. Be ready just in case. Hopefully it doesn't happen to you, but if it does, knowing that you're ready will make us feel so much better. And even knowing that you took action is great. I mean, it just feels like mission success, whether it's us, whether it's the meteorologist at the NWS, NOAA, no matter who you're at. Even broadcast meteorologists don't feel like they've done their job if they're spending hours and hours on air, but you don't listen to them or take action, right? You can ask any broadcast met, whether they're, broadcast media, multimedia, National Weather Service, NOAA, no matter where the meteorologist is, if they know that you took action, dude, that'll make their day in a heartbeat. Just being honest with you. So that's the main takeaway here tonight. So with that being said here, guys, we're running late. I apologize, but it's been good. 9 o'clock here. We'll go ahead and hop off here again. If you guys missed anything, I do encourage you guys to rewatch this video. We talked about a lot, I know. If you forget something, this is a great way to go over that information, whether it's tornado safety, severe weather statistics, whatever it is. Feel free to go back and rewatch. And let's all have a safe severe weather season in 2024 or 2025. Again, that's another sign it's getting late. Caleb's in the wrong year. But again, let's all have a safe 2025. And we will see you guys next time we do a video. And again, thanks so much for spending time with us here on this workshop. It's our first time ever doing one here with Indiana Storm Chasing Network, and it's been a blast. Loved hanging out with you guys. Again, you guys all passed the test. See, I told you would. You guys were sweating when I said test, but it was all good. So again, thanks for hanging out with us. If you guys have anything you need to rewatch or anything, I encourage you to do so. And we'll see you next time. And hopefully we won't have to go live here in the near future for a severe thunderstorm warning. But if we see that threat, we may. So with that being said here, guys, we'll hop off. Have a great rest of your evening and enjoy the nice weather we have coming up here for the next couple of days. Fall spring number 3 or 4. We'll take it, right? So with that being said, thanks for joining us. We'll see you next time. Take care.